In this demo, I will show how we can use structure edits to build a program from scratch. Structure edits directly manipulate the abstract syntax tree, or AST, allowing us to develop quickly without the risk of introducing syntax errors. Most editors only permit conventional text editing along with a specific set of refactoring tools. But Sketch and Sketch also supports general-purpose structure editing commands that allow the developer to build a program from scratch without text editing. We can use either the keyboard or the mouse to input these commands, but as a Vim user who doesn't like moving his fingers from the home keys, I'm mostly going to show keyboard-centric structure editing. For this demo, I'm going to show how we can implement mergesort to sort a list. The particular algorithm isn't important, so don't worry about the code I write or what it means. The interesting part is how I use structure edits and refactoring tools to develop it. First, we'll write the merge function. As you can see, the merge function is currently set to be a hole. A hole is a node in the AST which doesn't have a semantic value yet. A hole is basically a part of the program that we haven't written yet, but we need to write later, and so with holes we will use structure edits to replace holes with other types of AST nodes. So we click on the hole, and as you can see now, this brings up some a deuce menu that allows us to manipulate this AST node, and especially these are the structure edits allowing us to change the hole into any sort of AST node, any sort of program component that we would like. If we set this to something, then we can delete it, and by deleting it we replace it back with we turn it back into a hole essentially. So we can turn holes into normal program components, and we can delete normal program nodes by turning them back into holes. So we have this menu which we could do all these things with, or we can use the keyboard. As you can see, I've implemented H, J, K, and L, which are Vim ways of doing arrow movements, but also we could use regular arrow movements. And it's a little bit janky. This code is kind of a hack, but as you can see, we can kind of use left and right to move through the tree nodes in essentially a pre-order traversal, and we can use up and down, which will heuristically go up or down a line and also find the tree node whose span within that line closely matches the span of the original tree node from which we moved. So we can use the arrow keys or HJKL to move around. And then we also have shortcuts for all of these menu commands here. We have keyboard shortcuts. So let's see what the keyboard shortcuts are. We're going to press Control close bracket. It's kind of an arbitrary choice, but really anything that it doesn't matter what we choose as long as we choose something that works in the browser. So as you can see here, we have the movement. We have movement within menu. We can toggle, we can move through the menus using the keyboard as well. We can select items with control space. I'll show that later. We can go to the next or previous hole. We can delete something. We can rename. And then there's shortcuts for creating basic program nodes. So naturally, if we want to create parens, the keyboard shortcut is an open parenthesis. If we want to create a list, the keyboard shortcut is an open square bracket. And so we have these fairly natural. Some are arbitrary, like case is E and let is T, but in general, most of these are hopefully fairly intuitive. So let's go here, and we want to merge it to be a lambda. It's a function. So we're going to type \, that's the keyboard shortcut for lambda, and then we can type N to go to this wildcard. The first hole or wildcard after this, our current position on the wildcard, we can press S, which is familiar to Vim users, to rename it to, let's say, list 1. And merge takes 2 arguments, so we're going to type Shift A. It's kind of an arbitrary choice, but it works well enough to add a child to a parent. So Shift A will find will work up the tree until it finds the nearest parent that can have a child added to it, and add a child. So we type N again. That moves us to the wildcard list 2. And so you can see how we're developing using structure edits and the keyboard. And you can type Shift J, this sort of like reformats. You type N to go to the first hole. And what do we want to add here? Well, we're going to want to add a case statement. So if we go look here, we can see that create case is E. So we're going to type E here, and that creates the case. As before, if we type Shift A, it'll go up to the next parent and add children to that parent. So we can just type Shift A here, and it'll add children to the case, branches to the case, essentially. And of course, we could do all of this. If we type N to go to the next hole, we can do all of this with the mouse as well. So we can do replace with tuple, or we could just press comma. Then, for autocomplete, let's show some autocomplete. Unfortunately, I'm not that good at getting the UI to look nice. So this autocomplete menu is in an awkward place, but if we start typing the name of our variable, it narrows it down. And if we type enter, it'll do the first one in the list. So list 1, type N to go to the next hole. We can autocomplete likewise. And as you can see, the autocomplete has like basic functions like plus, minus, times, basic operators. And it also has library functions. I've only included the library functions that are necessary for this demo. But as you can see, we can use autocomplete for library functions as well. But right now we just want list 2, so we can do this, and then we can select from the menu with the mouse, or because I like to use the keyboard, I've created some arbitrary keyboard shortcuts that let us move through the menu. So that's pretty straightforward. And then we'll do likewise here. And we're just going to fill these out real quick. So, here I can type colon to create a cons. So here we're going to have a conditional, which we do with C. And I'm going to reformat it as I did earlier. And as you can see, the formatting here is wrong. So there's, again, some of the code here is kind of hacky. So for operators, we can just type the operator. So I just typed the angle bracket, and it automatically goes into the autocomplete with that angle bracket pre-populated. And so here we're just going to H2, H1, and then here we're going to press space to change this into an application. That's the shortcut for application. As you can see, that will be like this. And with application, naturally, we could have application to multivariable functions. So you press Shift A again to add a new child to that application. So we're going to type I to, so if we want to find a variable, we just type I to go to autocomplete, and then we start typing the name of the variable, and then it chooses the first one if we press enter. Now here, we want the same structure in both the if and the else branch. So what we're going to do is we're going to use control space to select an item, and then we can, with multiple items selected, we can use our powerful Deuce refactoring tools. So now that when I go here, I'm going to go into the menu, I'm going to go to make equal by copying, and I'm going to go into the submenu, and we're going to copy this expression to here. So that's pretty useful. That kind of gives you an idea of how we can do structure editing with either the mouse or the keyboard. in order to build a program from scratch. And as you can see here, although we did have some formatting jankiness that can be fixed, but otherwise, by doing it with structure edits, we didn't have the potential of creating any syntax errors. And also in the next bit, when I develop mergesort, I want to show that we can also use structure edits to develop programs quickly. Maybe not as quickly as conventional text editing in this current system, but still fairly fast. And I want to, even if it's not quite as fast as text editing, I want to get across the idea that it might feel more fluent than text editing, where we have to think at the granularity of individual characters, which are kind of error prone and arbitrary, instead of thinking at the granularity of AST nodes, which is the real granularity of a correct program. So let's run the program as is, and we can see that we have this list, a random list. Alright, so now we'll develop mergesort as quickly as we can, and then the list should become sorted. Alright, so we've completed mergesort pretty quickly. As you can see, when we run it again, the list is sorted now. So as you can see, with the keyboard-centric structured edits, we can create a new program fragment from scratch pretty quickly. It's not quite as quick as conventional text editing. I think there are some ways that it could be improved to make it a little bit faster, tighten some screws, and hopefully get it up to the same speed as regular text editing. But for now, I think that for a first demo, this is pretty efficient. It's, of course, fairly rehearsed, but in practice, you're usually doing more thinking in between your edits, so I think this is efficient enough for most purposes. And thanks, of course, to Michael Meyer, who developed the CSS and HTML here to make this nice visual of the list sorting itself.